Hello everyone, and welcome to our webinar on pioneering a new era for site survey, the system integrators approach, featuring guest speakers from Betacom and repeated signal solutions. My name is Elsa Libby, and I'm part of the marketing team here at iBwave. I'm thrilled to report that we once again have a great attendance rate today with a wide diversity of participants, which should lead to a very interesting and engaging discussion. So thank you very much for taking the time to join us today. So before we begin, I would just like to go over a few housekeeping items. So first of all, I will be sending a copy of the presentation as well as a link to the video recording of today's session via email tomorrow. Secondly, you're welcome to use the GoToWebinar question panel to ask questions at any time during the session. We'll try and answer as many as we can during the last 15-20 minutes of the session, or as time allows. Also, we'll be using the GoToWebinar polling function today, so we can get your feedback on a few aspects of the presentation. So essentially, when the poll pops up, you can simply click on your desired answer, and we're going to tell you the responses instantly so we can share them with you. Finally, for those who might be experiencing audio difficulties, please know that we will try to speak as loudly and clearly as possible, but please make sure to check your own audio settings on your computer or your phone as you dial in as well. So for today's presentation, I'm happy to have three great speakers who will each cover different aspects of the topic. So to kick off the webinar, we will start with iBwave's VP of Product and Innovation, Benoit Fleury, who will talk about the site survey, the key steps and the objectives, as well as the challenges and opportunities in terms of time and cost. Our second speaker is Repeated Signal Solutions VP and COO Pete Borley, who will share his insights into how to optimize the in-building design process with iBwave mobile application. Our third and final speaker will be David Paolini, Director of DAS at Betacom, who will expand a little bit more on site survey cost and process and talk about the efficiency of the iBwave mobile nodes and the cost saving enabled through iBwave mobile and cloud. So we have a lot of great content for you today, and without further ado, it is my pleasure to introduce our first speaker, Benoit Fleury. As VP Product and Innovation at iBwave, Benoit is responsible for evolving iBwave's current products as well as expanding the company's overall product portfolio. As such, he drives the definition and launch of new products and services while also working with partners to offer complete in-building wireless solutions. Benoit has extensive experience in the telecommunication industry, ranging from startup to large global corporations. Throughout his career, Benoit held senior positions with network equipment manufacturers, test solution companies, and an emerging mobile operator. So Benoit, it's over to you.
Thank you very much, Elsa, and hello everyone. What I would like to start with today is giving you a quick overview of iBwave and the market dynamics that we're addressing. So the company was founded in 2003, so roughly now 11 years ago, and we're really focused on providing solutions to plan, to design, and deploy in-building wireless networks. And that's regardless of technology, regardless of architecture, independent of equipment vendor or type of venue. Now what was niche 11 years ago is now pretty much global and mainstream insofar as properly planning and designing in-building networks are concerned. So we operate globally, and we now serve over 600 customers in some 85 countries. And the market for in-building wireless systems, and again, whether we're talking here about DAS systems or small cells, Wi-Fi, public safety, is quite a healthy one. And that's in large part due to the proliferation of smartphones and increased appetite for higher data traffic, most of which, as many of you know, is accessed indoors. What's interesting is that only about 2% of the world's office space is covered with adequate coverage capacity. So there's tremendous growth potential. And that's not counting other types of venues such as malls and subways and stadiums and so on. Also, the network is becoming increasingly complex, and that's in order to maximize the end-user experience. So what we're seeing here more and more is a mix of different types of technologies that are all required to interact seamlessly. So that pretty much sets the stage for the in-building wireless market. And now if we can take a look at the key process steps here. So before diving in the site surveys and the focus of today's webinar, let's first take a high-level look at the planning and the deployment process of an in-building wireless network. So first and foremost, once we've determined where there's a need for improved coverage and or capacity, well then the first step is to assess and survey that site. From there, we need to dimension and plan the in-building network. Once that's done, the next step is now to perform the detailed design. Typically, this would be done by an RF engineer that would sit somewhere in an office at a different location. And what follows after this is the installation and commissioning process, and this would typically include a test and an optimization phase. Finally, this network will need to be operated and maintained over a course of its life cycle. Now, this process will repeat itself down the line when there's a need to either increase the capacity or upgrade the technology. So that's the overall process. Now, iBwave offers a suite of products that not only address the planning and the design stage, but also the pre-design phases, i.e. site surveys, and also the post-design process, like, for example, performing as-built documentation. So site surveys are really important, and those are the main topic what we're going to be talking today, because they're at the beginning of that process, and how they're done will have a direct impact on the effectiveness of the subsequent steps, so namely design and deployment. So let's now look at site surveys, but first, what are the main objectives of site surveys? Well, at a very high level, there are two main objectives. The first is to capture the key site attributes. So these will be things like the physical aspects of the venue, such as the floor layout, the materials which is used in the building, the equipment room and how much space there is in it, where it might be located, the location of risers between floors, et cetera, So that's obviously a key piece. But then the building access is also important, so such as security constraints to enter a building or perhaps parts of a building. Other things like time of day restrictions, which could sometimes be very particular, and so on. Electrical power, so items such as AC, DC availability, wiring, electrical panels, where they're located. And last but certainly not least is the RF environment. So typically here this will be the surrounding macro cellular network. That could very well cause interference in the in-building network that would limit data throughput. And that is particularly important for LTE systems where high data rates are required. So that's the first key objective. The second one is to document all the information that was captured in the survey and communicate it to the other stakeholders, typically, for example, like the RF engineer, and store it somewhere centrally so that it can be accessed by different people or different departments. So first, that's typically done by taking pictures, for example, of an equipment room, recording clips of audio or video to give more information, and of course take various text notes. And these would all be linked to those data points that we call annotations. So it would be important to geolocate these annotations against a floor layout so that they can be easily located by the designers or the installers later down the line. So that would be the two key at a very high level objectives for the site survey. Of course, there are challenges. The first is to get it right the first time. Why? Well, first of all, to avoid additional visits. So more visits will obviously add more time and cost to the site survey, so that's far from desirable. Completeness of the survey is clearly important. You don't want to return because you forgot to check something, especially when the venue is difficult to access or it's far to get to. Now, accuracy and quality are also essential for getting it right the first time, as this could directly impact how good the design is. And it could even be more expensive to correct at a later stage. So getting it right the first time is a key challenge. The second key challenge, I would say, in site surveys is to control time and costs. So it's not only about the time to perform the actual survey, but also to document it properly. Only too often that's done after the survey, and it can take a lot of time, especially if the notes and the pictures were done manually and separately. Plus, it can lead to errors if they're not sorted in the right order. So that's time. Other than time, there's also the cost associated with the staff that's needed to perform the survey. If a high level of RF expertise is needed to carry out the survey, then obviously it could cost more. So the question to ask then is, are the processes and tools such that the expertise level can be minimized in order to lower that labor cost? Thirdly, another consideration is the cost of the tools themselves to perform and to document the survey. And last but not least, scaling. So what do we mean by that? Well, we're talking here about how many surveys could be performed in a given period of time. So if we go back to the level of expertise that might be needed, highly priced RF engineers are not necessarily abundant, as you all know. So if that's the level of expertise that is required, well, obviously it's going to have a negative impact on the scalability of the process. So now we talked about challenges associated with the site survey itself, but these surveys will then directly feed the subsequent phase of design. So it's also important to understand the design challenges. And we're going to look at two different types of designs, as they may have different implications on how the site survey is carried out. So DAS systems, for instance, are typically required for larger venues that require often more thorough engineering. So large amounts of data will typically be needed, and there could be a lot more considerations to take into account in that case. So for example, in multi-floor towers, RF collection would need to be done at each floor, as they will not all have the same level of RF coverage. And then subsequent to that, an important step in the design phase is the integration of the collected RF data into the design file. With conventional tools, this tends to be a manual process, and it can take a lot of time. Plus, it's often error-prone. That would obviously further add to the time element. So that's one type of design. In contrast to this, small cell systems are typically used for smaller venues, such as office spaces, for which there are many more. So here, in this case, scaling becomes a really important factor. So therefore, the design phase needs to be faster and cheaper, and it follows that the site survey phase also needs to be faster and cheaper. Otherwise, it just won't be justifiable financially. So what that also means here is that in this case, it's even more important to get it right the first time, as you definitely don't want to have more than one site survey prior to the design phase, given the low cost and scaling needs of these types of systems. Okay, so these are the key challenges in terms of the site surveys and the design phase that follows. So now, so what's the opportunity in terms of streamlining the overall process? So the key goal here is to, one, simplify task and to streamline the overall process. So what we're enabling is to digitize all the notes, the pictures, drawings, video, and audio clips into a single file that's going to be compatible with the design phase. So we're talking about an iBwave file that is created right from the start during the site survey walk. And that's done with a tool called iBwave Mobile. Now, since the RF collection data is also part of the site survey exercise, well, that too needs to be integrated into the iBwave file. And again, ideally, right from the start. So once all this is integrated into a site survey file, it's then passed on to the RF engineer, who will proceed with the design based on all the information that was collected and geolocated during the site survey. So that's, as we talked about, the physical aspects of the site, logistical aspects, electrical, and the RF environment. Okay, now it does not suffice to only collect information. Well, it needs to be stored centrally for being able to be shared by any authorized engineer or other personnel to complete the overall design process. So here we can walk through a very simple example. Once a site survey is completed, let's say in a large office building or stadium, well then everything is integrated in the iBwave file that's generated from iBwave Mobile. Now this is then uploaded to a cloud space or a server and subsequently downloaded by the engineer that might be sitting in an office or in another city or even in some cases a different continent. So he or she would then complete the design based on the site survey information provided by the mobile file, and then once completed will then store it back in the cloud or the server, and then the completed design file can then be accessed by a person that's on site for either design validation, installation, and completing as-built documentation. So why is all this important? Well, it's because the chances are pretty high that at some point in the future an upgrade is going to be required, either to upgrade the technology or very possibly to add more capacity. Or perhaps some troubleshooting may be required to be done at some point as well. So it's important to have the latest documentation that's readily available and centrally stored, as people could move on in the course of the project's lifecycle. So I want to thank you for your attention here. What I described at a high level is an opportunity to significantly streamline the collection and documentation aspect of site survey data, and importantly, feed this in a seamless fashion to the design phase. And this is going to save a lot of time, cost, and also will ensure good quality. The next two presenters will provide more concrete examples of all of this. So that concludes my portion of this webinar. So thanks again for your attention, and back to you, Elsa.
Thank you very much, Benoit, for your presentation today. So as Pete gets ready to start his presentation, I'd like to take this opportunity to ask a question to get feedback from our audience. So the question is, has any of the following occurred to you or your organization during the design process? So you have a couple of options to choose from. And while you think about that, I would like to introduce our next speaker, Pete Foley. As VP CEO of Repeated Signal Solutions, Pete is responsible for the engineering, deployment, and support services. Pete is extensively involved with the customer at all levels through the design and installation process. Pete has operated in this capacity since 2007. Pete's background includes managing the Bosch Corporation Connected Vehicle Thematic Solution, managing the unified messaging product at Openware Systems, and overseeing customer deployments as a solution architect at Net Perception. Pete also worked in the Medtronic corporate IT group, leading deployments across the global network. So time is now up, and we're ready to close the poll and share the information with you. And so this should appear on your screen shortly. And I will now pass the control over to you, Pete, and ask you to maybe provide a few comments on the results, please.
Yes, absolutely. Thank you, Elsa, and thank you, everybody, for joining today. So it looks pretty telling. About 50% of the respondents indicate they've had lots of, I'll call it, artifact tracking issues associated with the survey, and that is not a unique situation. I think we've all suffered from documentation and details going awry, being misplaced, what have you. Therefore, adding some complexity and some redundancy to the process, and that's a lot of what Benoit alluded to. So that fits perfectly into where we're going. So we'll talk about how RSS as a company saw those same issues and why we're looking at iBwave mobile ads as the path to help streamline some of that stuff. So go over to the presentation now. Elsa, can you bring us onto the presentation, please?
Pete, you should be able to see your first slide now.
Nope, I'm still seeing the poll results. So while we're working through that, Repeated Signal Solutions is an in-building service provider. We've provided in-building solutions in the cellular space, public safety space. There we go. Thank you. For a little over 11 years now, based primarily in Southern California and working nationwide. Our activities include the direct enterprise work, direct carrier work. We also work with the neutral hosts from time to time. So we run the gamut of the different business models and the different sizes of the projects, working on everything from small office buildings to large campus environments, as well as stadiums and things of that nature. So, and throughout that process, as you can imagine, a lot of people, a lot of players are involved in making sure that we maintain the data from any given touch point with the venue is a critical element of producing our design and our solutions. Okay, so we take a step back and we look at what is it that factors into why we've decided to go with iBwave Mobile as a platform. Well, the design process, as you know, requires lots of different resources, lots of different skill sets and different expertise. So we've got people who are CAD experts in there, RF design engineers in there, system engineers in there, there's construction, there's subcontractors, and all of those players are bringing useful information to the table. Multiple touch points, even sales team, you know, all these players bring information to the table. And that sits with those individuals kind of into the tribal knowledge sort of form, and bringing together, and 50% of the poll respondents seem to indicate that this is a problem, bringing together all those pieces of data is a critical part to ensuring that the design is quality and that we're handling the operational efficiencies that we're looking for. Most people know that design does not equal to construction, and so you're just by performing the design, you're not 100% of the way there. There's still a construction element. And on top of that, I think everybody would agree that a picture is definitely more than 1,000 words, and benefits of doing that are highly important. One of the things that we're very focused on, and as an industry I believe that is happening, is the efficiency, the scalability of the design operation, if you will. The duration and cost associated with that. Benoit talked about the completeness and thoroughness associated with that, the cross-discipline impacts of that. All of that weighs into the cycle time. And iBwave Mobile is one way that Repeated Signal has looked at consolidating that information to enhance and improve the cycle time efficiency of our process. So as a turnkey provider, we provide all sorts of steps in our process. This is kind of an overview of what it looks like. You know, there's survey, predictions, et cetera. There's initial designs. There's, obviously, we have a project management, inventory component to what we do. All these different touch points come into play as you go across the life cycle of the project, even into the operations and maintenance. And what we've found is that the iBwave Mobile product actually fits in several of these steps. And there are reasons why we need to have information coming from the field back into the design team, et cetera, at each of those steps. And that's one of the reasons why we have embraced the mobile platform. So how are we using the mobile product? Creation of a design, either something that happens prior to the visit or in the field, more the former than the latter, but certainly it's nice to have that opportunity. And as we go through this survey, we're capturing information regarding the constructability, be it hardware locations, cable routes, et cetera. It could be things like power and open spaces and sleeves, even all the way to the path of details on how to access security and things like that. Again, the picture is worth 1,000 words, and if it's easy to hand over to somebody else and they can look at it and consume it right away, it's going to improve things. We're also using the mobile product to create or make adjustments to our designs. So as a designer has an initial layout with respect to cable paths, that's going to get updated by the due diligence that happens in the field. That can happen right there on the design file through the mobile platform, and then it goes back through the process so that it gets updated in the full formal design. So a couple of examples of how we've rolled the mobile product into our design and development process. So here's an example of a location in a stadium where we're looking at putting some antennas. We've got the photo survey taken through the mobile product. It shows up on the layout page as a push pin, and you can name the push pin. You can put more than a photo. We can have things like We can have a video annotation. In some cases, we do audio annotations where the surveyor wants to convey some important information to the designer. In this case, that photo also got pulled into the simulation that you see off to the right, which went out to the venue, it went to the architect, and ultimately at some point gets to the planning committee from a permitting perspective. Again, a very useful tool to help them understand what's happening. And then it shows up in the architectural engineering drawings that are put together for the construction team to look at as they go forward with construction. Pretty straightforward process. Having that capability in mobile gives it additional life. Right? The other players who are going to touch this design as it moves down the path have the access to that information as it's stored. Another example, similar sort of situation. This is an outdoor wall location for some macro equipment. You can see in the upper left here, there's the photo of the raw location. It being represented in the iBwave mobile product. You can see the layout of the floor with the pushpin location indicating where the photo was taken. That then made it into a photo simulation, which you can see in the next picture, and then ultimately into the A&E drawings for that location, where you can see the various representations of what that looks like. So that's a fairly common use case for us with respect to iBwave Mobile. Another scenario that we see fairly frequently with respect to that is on the prediction side of the product. So the product is more than just notes and annotation. You can also put together some preliminary design elements. So in this case, we've got a facility where we're doing a walk. We've imported the plans. We've defined the scale, relatively raw at that point. Then we move down the path of creating a set of zones. These zones are predefined densities that are set up in the mobile product. We then go through and identify, well, this is primarily an open space. There's a couple others that are higher density locations. We can insert our radiators on there, and then we can create a series of predictions. In this case, we've created a RSCP and a handover sort of prediction. The designation within the product right now, you can see these radiators are shown as small cell. We've used it for that sort of product. We've also used it to indicate a DAS radiator. And while these are not going to be the final design, these are certainly something that's very effective when we're meeting with the venue, meeting with players on site, to get an idea of, okay, roughly we're going to be looking at X number of antennas, or if we're going to have this many sectors in here, we're going to split it like this. So it's a very good illustrative tool that can be used in real time to make modifications and illustrate to people what's going to happen, what the proposal is going to look like. So our methodology, again, maybe just to refresh that a little bit, typically the iBwave design file is created prior to at least the basic file is created prior to the survey. That then gets pushed up onto the cloud. That file from the cloud is then pulled down onto the tablet, and then the survey is conducted out in the field, all those validation activities that we talked about. In the process of that, we're capturing the notes associated with the reality, be it photos, text annotations, what have you, and things that I mentioned earlier, power, grounding, space, all of those great things that tend to be a challenge. And we push that data back up onto the cloud, and then the design artifacts associated with that sit with the design. So out of that, we'll bring out photo simulations, presentation material that I alluded to, and obviously we're managing and maintaining the design moving forward based on that. So the benefits to this, I think this goes back to the poll question. One of the big emotional points is, why do design files typically vary substantially in some cases from what actually gets built? Well, it's the reality of the fact that a design is usually based on RF, and the construction may dictate something else. Well, as we all know, we try to true up that design file or maintain that as-built after the fact. There's a lot of cycle time that gets consumed at that point to make that happen. So the biggest benefit from our perspective is that the as-built and the as-designed are going to be very close to each other at the end of the day. And so that's what we hope for as we use this product. The survey efficiency, the accuracy, we talked about the scalability of the operations. that's a no-brainer, right? We don't have the digital cameras with the recollection of, wait a minute, was that IDF on level 3 or 7 or 12, what have you, because it's all geocoded right there as part of the design plan. We don't have situations where paper notes that were scribbled by somebody and are now illegible or get lost altogether. That problem goes away because it's all captured there with the design file itself. And ultimately what happens is the team as a whole is communicating better and moving data back and forth, and that leads to a more cost-effective solution and improves the scalability of the operations. Okay, so my last slide here, where are we going next? Well, I see that we've got, this multi-source data situation. Like I mentioned, we've got subcontractors and construction guys and RF guys and all these multiple sources. I see a need to be able to have that capability for all those players to provide input and that to make its way into the design file and give us ultimately control of what gets pulled into that or what doesn't. And then beyond that, the ability to use iBwave as a singular repository for all the design artifacts. And I'm talking beyond what we've mentioned at this point, but iBwave is working on things like pulling in benchmark data directly from those devices. I see things along the lines of cable testing data from the cable test process, getting that pulled in there. So all of that stuff lives with the design file as opposed to being scattered across the corporate network and potentially lost. And the goal would be to build that as-built catalog out of the design file itself, inclusive of all those components. That's all I've got today. I appreciate the opportunity to speak to everybody. Thank you, everyone. And Elsa, I'm going to turn it back over to you.
Thank you very much, Pete, for your valuable input and for sharing your experience with us. I will now pass the mic over to our third and final speaker, David Paolini. David leads the DAS division of Betacom, a full-service provider to the North American telecommunication industry. His division is responsible for RF and A&I design services, headhand, and DAS construction and integration and optimization of the completed installation. Betacom is actively serving the top 3 wireless carriers in the United States. Prior to Betacom, David led the customer-facing efforts of Gladiator Innovations, Trendium, and Optimize, software providers to the RF and system performance space. David, you now have the floor.
Great. Thank you very much, Elsa, and thanks to iBwave for putting together this presentation for North America. I represent Betacom, and we do serve North America. Professional services, including RF design and architectural and engineering services, as well as heavy construction, for example, the head-end rooms, BTS and DAS installation and maintenance of everything that we design and build. And I'm here today to talk about our experiences and our ROI on iBwave Mobile here in North America. To give you a perspective of how we're using iBwave Mobile, I'd like to tell you a little bit more about Betacom. We've been in business for 25 continuous years, and we're women-owned. We design, build, and maintain systems, DAS systems, as well as other network elements in the wireless industry. We self-perform all of our technical work, and we have a nationwide reach. Within the southeast region of the United States, we leverage the service centers of our other divisions for rapid material deployment and installation. And although it doesn't happen quite as much in DAS as in other areas of telecom, we have a very strong disaster recovery capability and are able to put systems back online very quickly for our customers. In terms of professional services, we have 2 main departments. Both use iBwave Mobile. First is RF. We do iBwave design, like most people on the call, with a particular focus on constructability. We really understand what is easy and what is not easy and what will ultimately be a more expensive way to do a system. So our focus is on constructability. We do head-end equipment layout, not just for the first installation, but for long-term, efficient cooling of the room, best for installation, and most importantly, ease of maintenance in the future. As part of our designing services, we baseline and CW test and optimize models. As well, we do all BTS and DAS optimization services certified by all of the major providers that we see here in North America. So in addition to the RF services, also we have A&E services. Elsa, if I could ask you to move to the next slide for me, please. Thank you. The architectural and engineering services are designed to help our customers improve the quality of their site walks, improve the quality of their scopes of work, and ultimately end up with a low-cost bid for a high-quality job. Our head-end IDF and remote location designs, I'll show you in a moment. We offer architecturally stamped and sealed plans that can be submitted for permitting, and we also offer permitting and inspection services to our top clients. Our head-end engineering, which is a big piece of what we do in professional services, focuses on every aspect of building the head end, including the foundation structure and the civil work, AC and DC electrical designs, structural improvements where needed, and most importantly, mechanical designs and thermal analysis, where we look very carefully at how the airflow in the room impacts the DAS equipment, the BTS equipment, and the power equipment, something that's become quite important recently. Some of our successful deliverables are on screen, and all of these were created using iBwave Mobile. On the left-hand side, we have some designs from our A&E department. You can see on the left some IDF and remote location designs. These pictures were taken with iBwave Mobile, and we did photo sims to show where the new equipment will be placed. Down below on the left-hand side, it's a little difficult to see on this slide, but this is a fiber plan for a very large stadium, including all of the directional boring underground and all of the conduit to protect the fiber. In both of these, because of iBwave Mobile, we're able to determine very accurately the distances of the fiber, the size of the room. We then use this for cooling requirements and all sorts of other calculations, all of which begins again with iBwave Mobile. On the right-hand side, most of you will recognize these are designs. All of these started in mobile on an iPad. So we have some opportunity to reduce the cycle time and the overall effort in the site surveys, but it's a little bit complex from Betacom. We enter at a number of different places in the build. Sometimes we enter at the very beginning. We call this a greenfield, and it's a building or a stadium, and we're doing the RF design as well as everything else associated. Sometimes the design is complete, and we're helping our customers create bid documents that they can give to construction companies and system integrators to bid on. Other times we are the system integrator, we're bidding on it, and we want very constructible designs, and we want to be able to deliver a very tight bid. Or in the end, we might be visiting an existing system, either for maintenance or to upgrade or replace a system for newer technologies. As I mentioned earlier, what we try to provide is accurate distances for the conduit, the coax, the fiber, very buildable design. We want to understand all the paths and the construction challenges and try to avoid those construction challenges to reduce the cost as much as we can for our customers. Most importantly, we want to make sure that our customers end up with question-free bidding documents and bids that are returned from system integrators that are assumption-free. Very clear, we meet all of the requirements in the scope of work. So this is our opportunity: reduce the cycle time, increase the quality, and reduce the effort. So as we've gone through this path of improvement, we started in the very beginning shooting pictures and taking notes, as most of you have. We find the site walk is really the smallest piece of the time we spend in this process. A couple of hours on the site walk. When we get back to the office, maybe an hour to transfer the paper notes that you took and the sketches from your pad of paper into the network and the office documents that you use to store on your network. It might take 2 hours to download all the photos. That part is pretty quick, but getting them organized, getting them named properly, making sure that you have the 3rd floor IDF and the 7th floor IDF distinct and you understand which picture goes where, very, very time consuming. Of course, you have to build your iBwave preliminary model, starting with your CAD files and building on up. That's the same across all of these, you'll see. And then once you have all these photos and documents, adding them as annotations to iBwave takes some time. So in total, we saw this taking about 10 hours for a typical building that we would do. Stadiums, of course, are bigger and might be 3 or 4 or 5 times this because of the different levels of the stadium. But I think you get the picture of the effort involved. We subsequently went to a cloud-based service to capture our photos. That saved us a little bit of time, actually, because we didn't have to worry about downloading the photos and renaming them. This was kind of automated by the cloud. Most of the things were the same, and you see we saved a little bit of time here, 1 hour, by moving to the cloud. That was pretty substantial at the time, but we were still looking for even better improvements. Our breakthrough really came when we licensed iBwave mobile notes, and we licensed this, gave it to all of our RF engineers. We built the iBwave model first in this case in iBwave Design, loaded it to the cloud, downloaded it to the iPad, and then did the site walk. What we found was so amazing about going from approach 2 to approach 3 was that every picture we were taking, every annotation, every note, everything we were doing was already geocoded to the right layer in iBwave, the right location in iBwave, and the RF engineer saw exactly where the IDF closets were going to be, exactly where the cable runs were going to be, and it was all synchronized perfectly back with iBwave Design in the office. This brought us down to very simply 4 hours, right? From 10 hours to 9 hours to 4 hours, and we were really tickled and very excited about the improvement. Also, there's a tremendous amount of ROI we'll get to in just a moment. But as we were doing this for a few months, we also realized there was one more benefit. And that benefit is we have been using extensive RF engineering people to go out and do the site walks. In some cases, we were flying these individuals from our central office to the stadiums and the buildings that were remote. So we had not only our best resources were tied up on these walks, but it was very expensive to move these resources around. iBwave Mobile is extremely intuitive, very easy to learn. Because of that, we were able to get our technicians who typically install and optimize these networks, they started doing the site walks on our behalf. And it still took the same amount of time, but now we're using much more plentiful resources, and we're using resources that are typically located much closer to the venues that our RF engineers tended to be. So if you look at the costs, and we've used some industry standard costs here. If you look at approach 1, notes and a camera, we were assuming every site walk was costing us about $2,500. When we moved to a cloud service, we saved a little bit of money, about 10%, but still over $2,000 per walk. Moving to iBwave Mobile, big step in the right direction. Now we were spending about $1,000 to do these walks. And then by enabling technicians to do these walks instead of our RF engineers, they have a different cost to us, and we saved even more money. So as you can see, we moved from $2,500 per walk investment to $500 per walk investment. And this really is just the time that we're talking about. In the cases where we were putting RF engineers on airplanes or we were driving them across the state, that was even more cost, and we had even more savings when we moved to technicians. So when we look back at the past year, across our A&E services, across our RF engineering services, our pre-walks and our post-walks, we were doing in excess of 150 site walks a year. So under approach 1, we were spending nearly $400,000 to do site walks, either as engineering services or to bid on jobs, and our current costs are significantly less. We're saving over $300,000 per year, all enabled by iBwave Mobile. So we're extremely happy with what we've seen. Elsa, that's my presentation. I'll pass it back to you.
Thank you very much, David, for your contribution. So we have about 10-15 minutes left, and we're now ready to take questions from the audience. We've already received quite a few, but if you haven't already done so, now is your chance to submit one via the question box in your control panel. So we'll start right away, and we'll start with you, Pete. During your survey, how do you get signal measurements and at the same time use the iBwave mobile tool?
Right. So at this point, we are not doing that simultaneously. That's not a functionality that we have available right now. I know there are some integration activities going on within iBwave, but we don't have that tool available to us right now.
Thank you very much. I have another one. It could be for either you, Pete, or David. What can you say about power over fiber that DAS providers are now looking for?
Pete, would you like to start?
Yeah, go ahead, David. Why don't you take that?
Sure thing, sure thing. So we've seen a lot of remote fed power applications, and we've done a number of installations where we see it makes a lot of sense. Most of the installations that we do are carrier grade, and most of the installations we do are very large stadiums. So it makes sense to have a central power plant, and it makes sense to have all of the remotes powered remotely over composite fiber. We do quite a lot of that, and I see, really in our world, I see that occurring more and more over the future.
Yeah, I would agree. We're definitely stepping up the number of systems that are remote powered that then have a power plant element, a trunking type capability, then it splits off from there.
Okay, thank you for you both. Is there a function of comparing prediction results with real measurements or combining them? So again, this one can go to either of you.
Oh, I can probably talk to this
Benoit,
one.
you can take it.
On this one, not within the iBwave mobile tool. So just to clarify, so iBwave mobile is in fact two different products. There's iBwave mobile note, and there's iBwave mobile planner, which does a little bit more, such as generating propagation maps. So, but even in that case, we don't do a comparison per se on the mobile device, but that functionality is available when you push that information onto iBwave design, and then with the right modules, you can import collected data and perform these comparisons.
Thanks, Benoit. So still with you, can survey notes generate survey reports? A similar iBwave report that shows photos per floor and labels so that clients can take a look at the summary and quickly approve or disapprove the locations?
Well, at this point, the reports can be viewed using design. They can also be viewed using iBwave Viewer, which is available at no cost. What we're going to be doing is, over time, adding more report capabilities in the next releases. But initially, you can do that using Viewer or iBwave Design.
Thank you very much. What file size are generated for this app? This is coming from someone who is concerned about the data size versus the cloud storage. Pete, David, do you want to interject?
Yes, I'd be happy to. So when we do our site surveys, we take quite a lot of pictures, and we do find that the file size is quite large. I cannot speak to the actual size. I think in some cases we've seen sizes over 1 gigabyte. We definitely finish our site survey and make sure that we're in good network coverage, either 4G LTE or a good Wi-Fi location, to begin our upload to the cloud. It's not something that we would try to do inside the venue, especially if it's a greenfield. But really the transfer is quite seamless regardless of the file size. We've seen some extremely large projects in stadiums and lots of places like Google, Starbucks, where you can upload extremely quickly. So hasn't been for us any hiccups.
Yeah, and we typically have that that movement of data happen on a Wi-Fi network, be it at the office, what have you, and even though we do have the 4G capability, this is one of the things that came up, I think, in the iBwave user group meeting in October relative to all these different artifacts, and as we add more and more into the repository, how is that going to get handled in the and the design file size and things like that. So I know that on the iBwave side, that has been flagged, and my presumption is they're looking at a way to help through that problem.
Yeah, I can add to that just to acknowledge that, so that was raised and we're aware of it, and working on the different ways to store the information, especially dealing with the media aspects of the file. So we're looking at treating that differently going forward. So we're definitely working on that one to make it easier as the files get larger and larger.
Perfect. I have two questions for you, Pete. So what features have you used the most in the iBwave mobile platform, and how easy is it to adopt it in your production process?
Right. So by far the most common feature set that we're using within the platform has to do with the annotations, be they the photo elements or the spoken elements. It tends to shorten any issues associated with communication and allows people to see exactly what they're looking for. Plus, it's something that we can go back to time and again. We don't have to find the right person who was at the survey because that photo is embedded within the design file. So I would say definitely the annotation capabilities are most critical for us. With respect to adoption of the product, there is a change in process. There certainly, and I think David walked through it on his side as well. Our process in the past, before we adopted this, didn't necessarily require a cloud element because we kept things local on the corporate server. Now we've had to adjust. We've had to put a couple links in the process to facilitate, for example, movement of the design file to the cloud, back down to the device, et cetera, in both directions. So a fairly simple a simple process change to make, nothing horribly egregious. And then the other side of it is actually getting people to use the product, to break from the patterns and the habits they've formed over time. But as soon as we sit down and we do one design review and people see the fact that we can drill in and answer the question right away, they recognize the value. So relatively simple to adopt, does require some process change, but again, at the end of the day, it's been embraced by everybody on our side.
Thank you. I have two questions for you, Benoit, in relation to the iBwave mobile platform. What are the prerequisites for the software to add the mobile app? And the second is, are licenses for the mobile notes or mobile planner floating or tied to individual device addresses?
Okay, so the first question is there are no prerequisites. So the iBwave mobile app, which runs on Android devices, is a standalone app, so it can be downloaded from the store, and does not need any prerequisite in terms of other iBwave software. And the second question was, oh yes, the licenses. No, they're not floating. The licenses are tied to the devices, so they can be used by multiple users, but assigned to a particular device.
So we're running out of time, so we're just going to take a couple more questions. So one for you, David. What employee type have been successful using iBwave Mobile for site survey?
Oh, that is a great question. In fact, that might be one of the main things of the presentation. We started out using very expensive RF engineers and flying them around, and moved to technicians, and that was very successful. But even since then, we've expanded the number of people that are using iBwave Mobile. Our engineers on the architectural and engineering side, architects, our management, construction managers, most everybody in our DAS division has used iBwave Mobile Note, and it's quite easy to pick up, and we've had great success with everybody using it. So whoever happens to be at the site can immediately bring up a tablet and start taking pictures, annotating, and getting information back to the RF engineer. That's on the pre-walk, the site survey that we're focused quite a lot on, but it's also at the end for the as-built. It's extremely compatible with all of the functions within our department.
Thank you very much. So one more question here for you, I believe, for Pete. Has there been any quality checks with the prediction and actual deployment results?
Can you repeat the question, please, Elsa?
Yes, absolutely. Has there been any quality checks with the prediction and actual deployment results?
Comparing the predictions in the mobile product versus the as-built predictions. Great question. So RSS, as part of its deployment process, does a pre-post comparison relative to the design in the design file. the iBwave design file. So what that means is after we go through the process with mobile and it gets pulled back into iBwave design, that's where we do our work. So we're comparing against the predictions that show up in the design file through the prediction components within the prediction module, not with the prediction that gets done in the mobile. So the technical answer to the question is no, we're not comparing against the predictions we see in mobile, but the practical answer is yes, we're comparing against predictions that come out of the prediction module on the design side.
Thank you very much. I appreciate that. So we're almost out of time, so we'll take one final question, and I will assign it to you, Benoit. Let's see. Is there a plan to change the licensing structure to floating format or to offer floating licenses as well?
Okay. Well, not in the short term. That's not the case, but it's something that we could perhaps look into at a later phase. But in the short to medium term, there's no plans to change the licensing structure.
Okay, well, unfortunately, our time is now over. So I would like to take this opportunity to once again thank our speakers for their great presentation. Thank all our participants for joining our session too. We hope that you found it informative and useful, and invite you to join the iBwave LinkedIn group where we can continue the discussion. You can also follow us on LinkedIn or send us an email directly. So finally, you can look for the webinar recording and the slides in your inbox later on this week. So once again, thank you very much for attending and have a great rest of the day. This webinar is now over.